Okay, so my name is Roland Bock. I'm head of development at P-Pro, and I want to talk to you about this library that I wrote, this sqlpp11, and a few selected template patterns that are used in this library and are hopefully useful for other people as well. So this is the outline. So first I'm going to give you an introduction to the library, so that you know what we're talking about, and to set the stage, and then some template patterns used in this library, and to the end I'm going to give you an outlook of what else could be done with this library in addition to the obvious stuff, which is using it as a front end for SQL databases. Okay, string-based SQL. That's basically motivation for why this library even exists, because there are quite a few SQL libraries around. So who can read this? These are commands to create tables in SQL. And as you can see, there's things like auto-increment here or bool here. These are vendor specific because not all databases have the same syntax. Okay, so I think that's one of the big problems, or at least for me, that's one of the big problems with SQL, that there is a standard, but even so, the code that you write is vendor specific, and I didn't even add all the stuff that you could add in addition, like encodings for tables and stuff like that. Okay. Then there's also many ways of making mistakes in SQL statements. So if you take just these two statements, you can read them. So it's inserted into customs and some things. So it starts with a typo. So it's probably not customs, but customers. If you read the rest of it, then we have a postal code here, and somebody wanted to enter a number, which is maybe wrong. At least in Germany, would probably be wrong. Then we have an address here in the city, and if you look closely, you will see that okay, Stavanger, well, that's the city, and that's the address. So these are switched. Then we have select from orders. This comma here, well, probably doesn't belong there. And then, well, more stuff like another typo here, and then a typical mistake for C++ programmers who try to write SQL using the double equal. That's of course not valid. So these are all mistakes that you can make, and there are many more. And I really don't like to make these kinds of mistakes, but it's not that bad, because it's not extremely bad, or as bad as it sounds maybe, because you get immediate feedback if you're using an SQL database client, right? So you type in the statement, and you hit enter, and if you did something wrong, at least in the syntax, then well, you get immediate feedback. It tells you that this is wrong. It's still vendor specific, but yeah, it's not so bad. So based on this entering strings into clients, there are many databases around which also use strings to interact, or to programmatically interact with the database. And I think there is a big problem there, because the immediate feedback is gone. You can compile this thing, this string here, it's just a string for the compiler. It doesn't know anything about selects and whether these columns are actually columns of this table. And then later on, if it makes sense to try to access the first or result parameter with the index 1, or if it makes sense to access one with a name n, because it doesn't understand any of this. And so this, at least in my eyes, turns into a maintenance nightmare, because I mean, if the query is as simple as this is, okay, it's not too hard to get it right. But as soon as I have some more parameters and some more columns to evaluate, if you have changes in your table definitions, maybe have more complex queries, this gets hard to maintain, and you will get the feedback that you did something wrong only afterwards in tests, if you're lucky and if you're very good at testing, and otherwise maybe in production. So when we write the code, we know the exact structure of the statements, but we know columns and all this stuff, but when we hide this information in a string with no types, nothing, so the compiler has no chance to tell us anything. And okay, so that's just what I said right now. Yeah, but bugs wait until runtime. The code is still vendor specific because we're writing strings. The strings are vendor specific. So if we want to migrate to another database one fine day, it's going to be hard because no tool will really tell us whether we're doing it right or wrong. Okay, so why should we use it? I say we just shouldn't. And there are alternatives, and one of those is this library that I wrote. I started with it a few years ago. sql11 teaches SQL to the C++ compiler. It is an embedded language which allows you to tell the compiler about the database that you're going to use, the tables and columns, and you can express the structure of your statements to the compiler, and you will get structured, well-defined results. I'm going to show you a few examples of what this means, and you will get immediate feedback when you're doing something wrong, because the compiler now understands what you're doing. It doesn't just get a string, it really understands what you're doing syntactically, and can tell you if your SQL query is wrong. And as a nice side effect, expressions are vendor neutral, except for those very few cases where you really need a vendor-specific feature. Then you can use that, of course. Okay. So here's a general layout how this works. You have a library called sql11. There you can create vendor-neutral SQL expressions. And you have a database which, of course, is vendor-specific. That's the nature of these databases. And you have a connector library which translates between these two. Yeah, we're going to see in more detail how this works later on. So now let's see some examples. So yeah, here's a select statement. So as you see, it's not a string anymore. So we call a function called select. We say, okay, from a table called P, we select the columns name and quirk, where the ID of this table is greater than 17 and the name is not equal to Z. Now, the library will tell you if, for instance, P is not a table, that you're doing something wrong. If name and quirk are not members of this table, or if you're using some more complex expression here, and you're using tables in these expressions which are not in the from, it will tell you. It will also tell you the same with these expressions. It will tell you if ID cannot compare to a number because maybe it's a string. Same with names or functions like the like functions or concatenation or so. That will work only for string-like fields. And again, if you're using or if you're referencing tables in these expressions which do not belong to one of these in the from, then the compiler will also tell you. So it will tell you about a whole range of possible mistakes that you can make. And then renaming columns, for instance, is not a big deal anymore. And in the same way as it controls what you're doing or checks what you're doing in the statement phase, you can also rely on the compiler to tell you if you're doing something wrong in the result evaluation, because these names and types that you have in your selected columns are reflected automatically in each of the result rows. So the row has a number called name, and this corresponds to a string value. So you can assign this to a string, but you cannot assign this to an int, for instance. Does that make sense? Questions about that? Okay. Cool. Can go even further. Sometimes we select columns with the same name. So we have two tables here joined in some way. So we have a P and a Q table. They both have a column called name. So if we don't do anything about that, this is going to give a name clash, which the compiler will warn us about, of course. But what we can do is we can use the same as in SQL. We can say, okay, as, and then a name. We have to define the names, of course, somewhere. This is done by these macros. And then we say, okay, we select this name as left, this name as right, and then we have the members left and right in the result row. And of course with the correct type. Yeah. Okay, and this is just showing off that there are a lot of more stuff in this library. I'm aiming to more or less have the complete SQL standard in this library. I'm not there yet, of course. It's not that old, but you can do quite a lot here. So you can select, for instance, all columns of a table. Here you have sub-select statements that you can use in all the places where they belong to. You have group by having and so on. Okay. Now, what if I do something wrong? As you may have guessed, this is a heavily templated library. That's also you can also guess that from the title of the talk, of course. And template libraries often produce this fear that, okay, I'm going to be seeing tons of error messages spilled all over my desktop, and that is something to be afraid of. So what I'm trying to do is to make error messages as short as possible and as precise as possible. So if we're doing this mistake here, quirk is an integer, and we try to assign a string to it, then we're getting this. That's the whole output of Cling 3.2. And it just says, okay, there's an invalid assignment operand. That's the first line. And the second line says, okay, here, at this equal signs there, you're doing something wrong. And of course, that is also a work in progress. Not all error messages are as short as this. But if you get really long error messages, I would consider that a bug in the library. I'm going to show you another example. So, I mean, that first expression was very, very simple. This is much more complex. So we select all columns of several tables, and then we have a where condition with at least 2 expressions here, and this one is wrong. This is a bool, and we try to compare it to a string. This shouldn't work, of course, and the compiler will tell us that that this is wrong. And this again is the whole output for this expression. So it's not that bad. It's not ideal. It's not that bad. It says invalid operand type. And something about the equality. It's not, third line, and on the 5th or so line it tells you that, okay, this comparison doesn't really make sense. Okay. I believe these are quite readable, and well, I really try to condense them even further. Okay, so well, that was basically everything I wanted to say about the library as an introduction to what it does. Much more to be said, but that's not really the topic of this talk, so I just wanted to set the stage for the template patterns that I'm going to show you. So, any immediate questions about this library now?
Perhaps how much does your library depend on SQL, but maybe it could be convertible to every kind of select statement apart from SQL, for example?
Oh, that's a cool question. We're going to get there in the last part of the talk.
Could you maybe go back 3 pages back? Pointing arrow again. Again. Sorry. Oh, it's not speak. Again. Oh, okay, he's cheating.
I'm sorry. Yeah. So
okay.
This is a PDF file, and all the animation is done by other. So
can I have any order of this group by having order by limit offset? Or do I
yes.
have to follow exact order?
You can have any order you want.
Any order I want.
And
that's offset first and...
Yeah, and if you... well, it's not completely true. I think you have to use the from first, so that it has a set of tables to compare to.
Okay, and then I can do what I want.
Then you can do whatever you want.
Okay.
Yeah. Okay.
What is P?
How
do you generate it?
Sorry? Okay, yeah, we're getting to that in a few slides. Okay, P is an object which stands for a table, and we're going to see table definitions.
How much do your error messages depend on a specific compiler?
Yeah. It certainly does. So the error messages that I showed you were Clang 3.2, and the other compiler I test with is GCC 4.8, and yes, GCC does produce more error messages, but it's and like factor 3, I'd say. So it's still not too bad.
And layout and readability and all this is, and if you put this into a, like, let's say Microsoft compiler or something like this, it's still something that produces.
I should not even work with Microsoft compiler.
Yeah, exactly. So Microsoft compiler currently cannot compile this because I'm using, I don't know, probably not all features of C++11, but quite a few, and several of those are not supported by any version of the Microsoft compiler as of now, unless they have to release something in the last few days. But okay, more questions? Right. So, template toffees. What do I mean by that? I mean small and sweet template patterns, and well, yeah, the same acquired taste. So if you don't like templates at all, then it's not going to be sweet at all. Okay. So the first thing is, since I stressed that in the beginning, that we're using names and types a lot, and migrate names from here into the row. Let's take a look at how this is done, especially if we look at something like this. So I really assign a name to something that had another name, and now this name turns up here. That is one of the important parts of this library. So if you ever want to understand what this library is doing and how it's working internally, you have to understand how this works. That's, I think, one of the key features. And I kind of hope that this is also usable for other scenarios as well. Okay. So the key to all this starts with something very small, and it's a template that has a member with a very specific name, which this is one of the columns in our table, this quirk thing here, and this member can be assigned or can be given any type. That's what we're doing with this template. So when we instantiate this, we can say, okay, we want to generate something that contains a member quirk, and we want to give it a certain type. And this is used like this, for instance. So you have a struct, and you inherit from this member template with an integer. Then this struct now has, through inheritance, a member called quirk with the type int. And does it make sense? Okay, cool. And this is how it's used. This is a column definition. So this defines a column called ID, and it contains a struct with all the name information. So for instance, a method that returns the string ID, which is useful for serializing the column. And then you see this member template, which has now a member with a name ID. Some operators that we could talk about later in a questions session if you want to. For a moment you can ignore those. It also has a value type saying, okay, that ID is some integer value, and you could also add some information about some additional traits for this column, like in this case, like it's an auto-incremented value, so you shouldn't assign a value to it because it's supposed to be read-only, stuff like that. Okay, but the important part for the next few slides is that the ID struct contains in some steps this member template, which has a member called ID, and we can assign any type to it. Okay? Then we have a table. So that I think answers your question about how tables are defined. Okay, and we go about that later. A table is again a struct with some inheritance that we are going to deal with in a few moments. It again contains this name struct, a function that returns the name of the table, and again a member which most of the time it's not needed, but it's sometimes handy to have. Right, and the value type says, okay, that this is not a value, so you can't compare it to anything, for instance. Okay, and the inheritance part really brings this table to life. And it inherits from a template called table. The first argument is the struct itself, and then the columns of this table. So this table has an ID column, a name column, and a quirk column, and these are added to this to the list of template parameters for this table template. Okay.
One question.
Yeah.
Why does the table still need a member? Aren't the rows already all of the members?
Sorry. Can you speak up?
Why does the table still need the member struct?
Most of the time you don't need it.